Every year, millions of cars reach the end of the road. But this graveyard is just the beginning of a remarkable transformation.
Every year, millions of vehicles reach the end of the road, but their journey doesn't stop there.
The journey begins with the dismantling of millions of old cars, many of which are heavily rusted after years of use. The heavy-duty crane swings into action, its massive grapple clamping down on the discarded vehicles, ready for the next stage of recycling. The massive hydraulic claw lifts the compressed cubes of steel, the first step in their journey to becoming new railway tracks.
Once compressed into manageable cubes, the vehicles are loaded onto specialized transport, beginning their journey to become new railway tracks.
After the initial crush, the cars, with tires still dangling, are moved along this massive conveyor system towards the shredder.
The first step in their transformation, millions of crushed cars leave the scrapyard, bound for the smelting plant.
These massive trucks haul the shredded metal, soon to be repurposed into new railway tracks. This is the full process of how discarded vehicles are transformed into the steel infrastructure of our railways.
Check the grade on this engine block. It's cleaner than expected.
Okay, updating the manifest now.
Each batch of crushed vehicles is meticulously scanned, logging the materials before they move on to the next phase of the recycling process.
In this massive facility, the hulks of countless vehicles are magnetically lifted and placed onto the sorting lines.
This battery needs the yellow tag. Make sure the date is clear.
Okay, securing it now. Next one's an airbag.
The process begins as the massive conveyor belts roar to life, carrying millions of crushed vehicles towards the shredder.
The first step is safely extracting all fluids, starting with the coolant, which is carefully drained into specialized containers.
Safety is paramount. Workers ensure that all chemical waste from the recycling of the vehicles is securely contained before it leaves the facility.
The battery, heavy and hazardous, is meticulously disconnected and lifted clear of the engine bay.
Here, the hydraulic press exerts massive force, stripping the rubber from the steel rims. The materials are then ready for the next stage of recycling.
The first step is the separation of materials. Robotic arms precisely identify and remove.
This massive crane lifts the recycled steel, the raw material for our new railway tracks. In this state-of-the-art facility, robotic arms precisely dismantle the car doors, preparing the materials for the next stage of recycling.
The process begins by safely shattering the windshields inside a reinforced chamber, separated glass from other materials.
Our old cars turned into railway tracks. It begins with the labor-intensive removal of the wiring harnesses, carefully separated from the steel chassis.
The shredded material moves rapidly along the conveyor belt. Here, the eddy current separator uses power. How millions of old cars recycled into railway tracks.
Once fully compressed, these blocks are ready to be melted down and reformed into railway tracks.
From this unrecognizable scrap, we begin the process of forging new railway tracks.
These massive chunks of recycled steel, compacted from millions of old vehicles, begin their journey towards the smelting furnace. Once the cars are shredded, powerful magnets separate the valuable aluminum, which cascades down, ready for the next stage of recycling.
The powerful electromagnet separates the ferrous metals from the shredded car bodies, the first crucial step in creating new railway tracks. Here we see the final stage. The newly formed tracks are precisely cut by a massive industrial saw.
We've got a fluctuation on the melt sensors. Reroute power to stabilize the arc.
Rerouting now. Levels are normalizing.
Next, an eddy current separator uses powerful magnetic forces to divert the lighter non-ferrous metals like aluminum and copper from the heavier steel.
The molten steel, recycled from millions of old cars, reaches temperatures exceeding 3,000 degrees Fahrenheit.
The molten steel, now superheated to thousands of degrees, begins to churn violently as impurities are burned away.
The molten steel, recycled from millions of old cars, is poured from the furnace. Spectacular shower of spark.
We are now entering the casting area, where the molten steel, superheated to 1700 degrees Celsius,
the molten heart of millions of recycled cars flows into the casting molds, beginning its transformation into new railway tracks. After the molten steel is cast, it is slowly cooled using precise jets of water, creating the massive plumes of steam you see here.
Emerging from the caster, these glowing billets represent the recycled material. They are rapidly cooled and cut.
These red-hot billets, once old cars, are now on their way to becoming new railway tracks. This is the full process of how millions of old cars are recycled and transformed into solid railway tracks.
What's the reading on the laser scan?
15.2 centimeters, right on spec.
Good, clear it for the next stage.
Once compressed and melted, the recycled metal is cast into these billets, the building blocks for the new railway tracks.
The recycled metal, now formed into billets, enters the rolling furnace, where they are superheated before the rolling process begins. The recycled metal is now superheated, glowing bright yellow as it is poured into the continuous caster. The massive rolling mill begins the transformation process, converting the recycled metal into new railway tracks.
Massive rollers compress the glowing bloom, slowly forming the precise rail shape required for the tracks. Here, the molten recycled steel is forced through the rolling mill, slowly taking the precise shape of a railway track. The molten steel, repurposed from millions of old cars, is precisely shaped and rapidly cooled to form the rail profile. This white-hot steel, recycled from old vehicles, is elongated dramatically by massive rollers, shaping it into the railway tracks of the future. These newly forged rails, once millions of discarded vehicles, stretch for miles, ready to carry the future of transportation. The water cooling jets activate, hitting the glowing track with high pressure to solidify the steel profile. Here we see the precision cutting stage, where the glowing hot metal is sheared to specification before moving down the line. The recycling process is complete. These new railway tracks, once old cars. Here we see the ultrasonic testing of the newly forged rails. This critical step ensures the integrity of the recycled steel. The recycled steel is then subjected to rigorous friction tests, ensuring the new tracks can withstand extreme conditions.
I'm seeing some variation near the rail web.
Let me cross-reference the thermal data. It seems within tolerance.
Precision is key. Laser scanners ensure every inch of the recycled track meets the stringent industry standards. The newly formed rails, created entirely from recycled vehicles, receive their final quality inspection and approval stamp. After rigorous quality checks, the newly forged rails are approved and loaded for their next journey.
From the scrapyard to the sunset, these tracks represent the culmination.
The culmination of the process sees the newly forged railway tracks shipped out, ready for installation across the country. Through advanced recycling, the old car is broken down and reforged into the tracks of tomorrow.